The octet rule states that elements gain or lose electrons to attain an electron configuration of the nearest noble gas. Compounds will have a neutral charge, meaning the positive charge cancels out the negative charge. When an ion is positively charged, it is a cation. When ions are negatively charged, they're called anions. For example, if you have a calcium with a positive 2 charge and sulfur with the negative 2 charge, the charges will cancel out. So in the example it says, find the formula of the compound that calcium and sulfur form.
To determine the name of an ionic compound, first you need to determine the cation and anion of the compound. Start by putting the name of the cation in the front, then put the anion in the back. Finally, alter the name of the anion and add "ide" to the end of it. First, there's NaCl, which will be sodium chloride, MgO, magnesium oxide, Al2S3 aluminum sulfide. As you can see, the amount of each element does not change the name of the compound itself. Here's one you can try for yourself. Determine the name of CS2O. Okay, time's up. The name was cesium oxide.
Transition metals will, no matter what, always have a positive charge. There are cations of atoms that have more than one charge. If you are attempting to locate transition metals on the periodic table, they are 38 elements between groups 3 to 12. Besides those elements, lanthanides and actinides are considered transition metals. When metals form cations, they must be written with Roman numerals, and those Roman numerals must be in parentheses. Exceptions are silver with a positive 1 charge, zinc with a positive 2 charge, and aluminum with a positive 3 charge. What is the charge of copper in copper fluoride? The charge of copper is positive 1, and its name would be copper fluoride with, of course, the positive 1 charge in parentheses.
Polyatomic ions are simply charged groups of covalently bonded atoms, the basic ones being hydroxide, nitrate, sulfate, carbonate, phosphate, and ammonia. For the Lewis dot structures, remember to add up all the valence electrons and the extra electrons or less electrons from the charge. So here's the example of phosphate, 32 total electrons, and it's placed in brackets with a -3 for the charge on the outside. Let's try the Lewis structure of sulfate. 6, 5, 4, 3, 2, 1. Okay, time's up. And here we have sulfate, 32 total electrons, and the Lewis structure here in brackets and -2 charge on the outside.